J'arrive pas à mettre les slides.
Y van dando, hostia, es un barco por eso, la verdad es que tengo un libro que cuenta vale, que sea antes. Y lo pueden dar, hostia. De color rosa. Y está quemado, está quemado y luego miro, hostia, sí, se está quemado y la chica está.
C'est l'heure?
Okay.
Hello everyone. So if you can take a seat, so we can start. So thank you for joining the NMRG session. So I'm Jérôme François. I'm co-chair of NMRG. Laurence Yavaglia, the other co-chair, is online, and with me today also to help me, Jefferson Noe, the secretary. So just to remind you the note 12, the first one regarding the intellectual property. So please read the slide and just remember you that if what you will present or discuss is covered by a patent or application of patent, you may have disclosed it. Also regarding audio and video recording, we remind you that the session is recorded. So if you go to the mic, or if you're online, you take you open your mic or your camera, this will be recorded. Also very important, the privacy and code of conduct. So we have to be respectful from each other. And here you have more detail about the different procedures and documents that are related to that. Again, we remind here also that there will be a recording during meetings. Although NMRG is a research group, so not a working group, so it's a bit different because it's part of the IETF that conduct research. So we are not aiming at developing new standards, even if we can, of course, publish informational or experimental document, but the goal of a research group is more to focus on longer-term research issues. Here are some links for the today meeting, so you may already have. I just recall you that you have to log in with Meeteco, so that we can track also the attendees. Video recording will be also available just after post-meeting on YouTube channel of the IETF. So before we go into the different presentation of the meeting, we want to make a short statement about the updates that we have in the group. So as you know, we have two documents that have been in last call, starting I think in December and ending in January. So one related to the challenge and opportunities management for game networking. So for this one, we think as chairs that there was no more discussion in the group, so very welcome document, but no more comments to be addressed. It's important to note also that the document have been shared and also introduced in the impact and with also positive feedback. So we will continue with the document, proceed to know this IRSG review. The other document, which was in last call, was related to the research challenge in coupling artificial intelligence and network management. And for this one, also good positive feedback on the different comments received, but also some comments, more in-depth comments requiring clarification and some addings. So a new version has been submitted, and basically I will, as a co-author, also I will present the modification either on mailing list or inter meeting or today if you have time. And for the rest of the procedure regarding this draft, I let the floor to Laurent, who is online.
Yeah, can you hear me?
Yes, perfect.
Okay, hi everyone. So the outcome decision for the last call on the NMRG AI challenges draft. Our proposal is that after IETF, we run a short 2 weeks final call for comments because there have been a new version and we would like to make sure this is reaching consensus. And the proposal is then to submit for IRG review.
Okay, thank you, Lauren. Regarding NMRG meeting, we started to have again a regular meeting. So the aim is to have monthly meeting. We are not at this stage because based on the availability of different people. But so we'll continue on that with different perspective for this meeting, either to work on particular topic like network digital twin or IBN, but also to work on the agenda revision of the group. Note that we may have an interim meeting which will be collocated with NOMS that will be in Seoul in May, but it has to be confirmed. So for the agenda of today, we have different presentations that you may have seen, so I will not enter into the detailed agenda. I just want to remind the presenters that the agenda is quite dense, so please really keep your presentation concise and in time based on what has been allocated to you. So I will invite first speaker, Shiva, who is online, and just put your slide. And I will give you control.
No, thanks, Jerome. So, am I audible?
Yes, we can hear you, and you should have control on the slide Sorry.
Okay, sure. Thank you. So, this talk is about the internet research at Deakin University, Melbourne, Australia. We have been building a foundation for developing experimental platforms and implementing internet protocol stacks in Linux, FreeBSD, and NS2, NS3 to plug machine learning models. Several independent and interoperable implementations are essential for the IETF, IRTF evaluation of the emerging TCP/IP protocols. So therefore, our focus is on implementing and make them publicly available as dynamically pluggable user and kernel modules for testing and experimentation by the wider network, industry stakeholders, and the internet community. For example, one of the main research focus in terms of implementation and experimentation is semantic communication networking. So this is the term I just carried from ITU, and then some of the members that are coming into in 6C meeting. To me, when I look it from the IETF and IRTF lens, it is not very far from intent-based networking. So the idea of semantic communication networking that 6C has proposed is like this. So until 5G, our focus was on technical communication problem, but now there has been real momentums in terms of research and development in 6C and proposing new ideas in 6C. And they are in fact saying that semantic aspects in communication has been overlooked by Shannon's theory. So we can clearly see in in the kind of 60 communication model, a pragmatic view of 60 communication model, and where we are trying to compare it with the linguistic, because linguistic and emergent of language is kind of, I mean, can be considered as the parallel developments in terms of our communication framework here. So overall understanding so far is like this. Yeah, we have been quite successful in terms of achieving label A, solving technical communication problem, but we do not have much progress or much performance in terms of level B and C, which is semantics and effectiveness, which is the main focus of 6C working group now. And in parallel, we have a very long history and a lot of like evolutions in linguistic, and pragmatics and sigmatics has been well designed and considered well thought there. So the idea that we have been thinking of is, hang on, yeah, TCP/IP protocols is already working fine. So technical problems has already been resolved. So why not we develop a kind of a two-way machine learning models where we can plug them in the application layer and help us realize semantic communication networking in some extent. So we have implemented a kind of, I mean, very two-way supervised hashing-based semantic extraction, which operates in the application layer, and it is on the Linux implementation framework. The maths behind it is very simple, like relaxation using regularization, but the implementation is based on supervised hashing for semantic extraction. For those who want to see the details, can go through the details in this preliminary publication available. So what is our idea proposing here is, hang on, while 60 is moving towards semantic networking, shall there be parallel moves from IETF in terms of considering and evaluating how interoperable will be it with the TCP/IP protocols that we have been experimenting and evaluating on, and shall we start developing experimental platform towards that? Next interesting problem that we have been working on is with CSIRO. So it is zero trust architecture. Yes, NIST has already standardized it, but the one that NIST standardized is basically centralized. Yes, we can in fact plug Google's federated learning and make it a little bit more federated in a sense like this, but that will federate only the authentication issues. Every other aspects of the trust and security in the network will be based on centralized framework. So it cannot be directly deployed in scenario like remote working or decentralized computing or kind of, I mean, fully distributed machine learning scenarios where we want to establish a trust there. So we came up with the kind of implementation idea that is again based on Linux and will be sitting on the top of transport, where we may have to integrate some of the federated learning ideas with blockchain or some other decentralized mechanism and make it fully decentralized uh, for operationalizing ZTA in a fully distributed networking environment. So in a nutshell, I have a figure in this slide here. So the one on the left panel here is the NIST standard, where we are kind of decomposing it in a modular way, dividing both policy engine and enforcement model as a software defined module, and then breaking the policy engine so that it can be operationalized in a distributed fashion. So we can see the components inside are basically kind of blockchain-based federated learning, where everything can be decentralized and both global and local learning can be done at the client end only in a fully decentralized fashion. And in terms of like policy enforcement as well. We can apply it in a fully decentralized fashion. Yeah. So this needs to be like maybe evaluated and experimented in the world. This is just experimental framework that we have proposed. The details, the preprint of the details is already available in the link. Please feel free to visit that and then give us your suggestions and comments on this as well. Next, very interesting works around this is like, yeah, multipath TCP has already been standardized. There has been moves towards multipath quick, multipath performance-oriented consistent control as well. But with this move of 6Z moving towards intelligent networking and learning, our protocols are not intelligent enough to be plugged into the 6Z frameworks. So why not we start rethinking about like how shall we plug machine learning into our model-based TCP protocols, for example, multipath TCP. So we have one of our recent work where we apply modular approach again. So our machine learning component, for example, DQL is sitting at the user space with communicating seamlessly with the TCP in the kernel stack. In fact, the multipath TCP and our intelligent agent as the user space are enabling interfacing and learning the actuations, which helps to capture the dynamic subflow behavior and then apply kind of experience-driven approach for the multipath TCP. Again, so is this the right time for us to bring experience-driven multipath TCP approaches and work towards that into IRTF or IETF or shall we form a working group? I think this is again kind of comments and suggestion we are looking from the community in this aspect as well. Similarly, we have been like working on several different versions of PCC as well. PCC is performance oriented consistent control. There is a multipath version of that, and then we are one of the first to implement like DDPZ, deep deterministic policy gradient with MPCC, and we clearly observe that yes, there is again in different network setting environments where the network is highly time varying, there is a big gain there. The implementation is already available in our GitHub. Please feel free to reach us and suggest us something. This work is again in collaboration with Comcast and Anwar Walid, which is kind of founder of multipath TCP Valia. We have been closely working with industries, but our implementation are quite in preliminary stage. So we want all the stakeholders and internet community to utilize the developments that we have done in terms of experiments and provide us feedbacks, comments where we can improve and make it more suitable for further evaluations in the wild, which is essential for IRTF and IETF to come up with this working group and going for a new standards on experience-driven multipath TCP. Yeah, next initiative is again along the line with the parallel developments in distributed as learning. So yeah, federated learning has been proposed by Google, and there has been a lot of moves towards distributed learning. But are we supporting well from the TCP/IP protocol stack for that or not? We have observed that there is a shifted bottleneck from computing to communication now, especially over wireless networks. We have observed in several scenarios that federated learning has been quite suffering a lot, and distributed as learning has all these stragglers, pioneers problem where some of the clients are really computationally efficient in a very good regime and communication is no more bottleneck in them, but while others are struggling to send their even parameters through packet based framework that we have in our TCP IP. So shall we go for a better approach here to help distributed as learning works in a desired fashion, in a better fashion? How can we address all those stragglers? So we come up with a very simple implementation by integrating model-based with these techniques, and then apply multi-pass TCP again for pooling bandwidth across various of available network links. Our findings are quite simple. We can see that DL can improve accuracy and efficiency and have more fairness over the wireless networks if we can integrate some of the ideas from deep reinforcement learning, and then apply it for driving the packets in the network. A high level view of our design implementation is here, where we implement the MPTCP DRL agent in the application layer, which talk seamlessly with the classic multi-path TCP protocols, and drive the network packets in a way that maximizes the network utility by communicating seamlessly with the DL applications running in the application layer. So the idea here is a kind of cross-layer technique as well, and some of the preliminary results of our implementations are available in our published work as well. This is also released for public comments now, so feel free to provide us your comments, suggestions. Try to run it in several different network environments, and please let us know how you feel with that. With this, I have presented several use cases on how we can potentially utilize machine learning towards the recent move in networking, including 6C moves, including moves from security angles like zero trust, and including other moves from like distributed edge computing angle as well. All of these experiences that I've shared here are colored with different projects that we have been working with. Anwar Walid, who was originally at Bell Labs, now moved to Amazon, and we have been closely working with Comcast. We do have some Comcast innovation funds. So Sebnam now moved to Tata. We are working with Zeph as well, and most of the security implementation that we are working with is also with the CSIRO team. Sridhar Nepal is leading that. We have a group of students in IIT Research Lab at Tech working closely with Jonathan, myself, and Genoy. So with this, I can open the floor for questions. Thank you.
Thank you, Shiva. Questions?
Just a general comment, if I've, by the way, this is Diego Lopez from Telefonica. A general comment is from what you were telling about semantic networks or how or semantic communication, how they were structured, etc. I see that this more related to the space of things like ICN rather than to network management. I mean, not that I'm not saying that it could not be a part of interest here in managing semantic content-oriented networking, but if you ask me a group that would be interested or would have the expertise to deal with this, I would say it's more ICNRG than NMRG.
Yeah, sure. Thank you.
I have also a question. So, Jérôme, but as participant, it's more a bit technical regarding, because you applied a lot, several times you applied reinforcement learning, deep reinforcement learning actually. And I was wondering if, in particular, in one of your last slides, you have this network representation that is based to learn basically that your agent can learn on a specific network representation. Did you look as well as how you can transfer the policy from one, we say, network and network representation to another? to avoid retraining the agent?
Yeah, that's a really good question. So we have not implemented that yet. So basically, our implementation is on Linux, where we do have these all like DRL agent running in different clients. But yeah, I think that could be the next step moving forward, like kind of federation of all these agents and then getting more global insights from every agent so that we can transfer back that way. Yeah, I think that's a really good suggestion. Yeah. We have not implemented that yet, so all of our DRL agents are independent.
Okay. Okay. Thank you. So there is no other question. So thank you again, Shira, and we can move to the next presentation. So invite Jordi.
Hi, this is Jordi from Qualcomm, and I'm going to be presenting a joint exposure of network and compute information for infrastructure-aware service deployment. This is a joint work with Sabine, Luis, Roland, and next. Yeah.
Yep.
Actually, can you skip this one? Next. Yeah, so I'm going to be starting with positioning the problem here. There's this trend where communication and compute are coming together. So with the belief that we've reached peak compute centralization, there's a need to actually scale up compute. You cannot throw more transistors to a single core. So you need to scale up by having multiple cores running in parallel, and that introduces the concept of communication to scale up compute. So at this point where we reach the peak centralization, there's a need to throw compute to be able to scale up compute. That means the two walls are merging together. And so if you look at the edge in particular, that's where we're bringing all this compute to the edge to be able to run these applications in the scale up. In particular, when you have both compute and communication joining the field together, you start having optimization problems where you're trying to optimize for both at the same time. And one specific problem is the application, what we call the application life cycle. When you try to deploy an application, say for instance at the edge, this application needs to be aware of not only what communication metrics you have, but also what compute resources you have. And so here in this simple diagram, we just show the service life cycle simplified. You could zoom in and have more components, but essentially you have two main stages. When you want to deploy a service, you have the service deployment phase. And after you deploy the service, you have the service instantiation or service selection. So a user actually connects to that service and uses that resource. And these are two different phases, but both of them require compute and communication knowledge. When you want to deploy an application service, you need to be aware how much compute you have, CPU, GPU, storage memory, and also communication metrics, latency, bandwidth, so that you can meet your SLA, say. In the case of deployment, who needs that information? So typically the service provider, the application service provider that's trying to deploy this application, say at the edge. When you go, once it's deployed, the application, you need to do service selection. So now the client typically needs to connect to the server and establish that communication and compute service. In that case, who needs this information? So actually both sides. In this case, the network operator needs to know compute and communication information because it might want to steer traffic through the network to meet certain requirements, QoS requirements. And then also the application, the client also needs compute and communication information to make service selection decisions, decide to which endpoint you want to connect that's going to meet the QoS requirements, say. So this is the problem space. If I want to go next. Use cases, the arrival of a new class of applications with stringent compute and communication requirements, say distributed generative AI, XR, VR, vehicle networks, etc. Industry trend. So we see this trend in other forums. So Linux Camera is discussing on the notion of reserving compute resources within the operator network. So again, compute and communication being two sides of the same coin. GSMA Open Gateway, working on creating APIs for developers that's going to provide such information so that when you develop your application, you can make such kind of decisions at design time. TGPP, network exposure functions, another example of the need to have a way to expose this information from the infrastructure. So the posit here is that there is a need for a structured, organized way to access communication and compute information from the network layer to avoid uncoordinated ad hoc mechanisms and ensure overall interoperability. So you want to go next? Yeah, use cases. On the left side, distributed AI computation, that's the example of hybrid AI. So as we know, we have different layers of compute and communication distributed from the data center all the way to the edge and then to the end device. And so when we do these queries, these inferences, there's a decision you need to make on where you actually run the inference. You could run it locally on the phone, or you could run it at the edge, or you could run it all the way to the cloud. And there's a trade-off, a continuum here of, between how much compute power you need. So usually when you go all the way to the core, the data center is where you have the highest compute capabilities. But then there's a cost on that because it's far away, there's a higher latency, as opposed to do the computation closer to the device, where you have maybe less compute resources, but lower latency, lower cost. So there's a need to make these decisions. And again, to support these decisions, you need to know this underlying information about the metrics, about compute and communication metrics. On the right side, the distributed XR computation, so it's very similar again. So in this case, instead of AI, it's an XR application. So I can probably skip that one. If we go to the next one, this one actually builds this analogy that, if you think about what we've been doing for the last 2 decades, if you will, on the edge side, the edge has been focusing on communication. So for instance, the problem of mobility, it's one of ensuring interoperability as you move from one base station to another, or even from one operator to another as you cross borders, that we must make sure that we have interoperability, that we have standards in the protocols on how we achieve this mobility. So the same concept actually that you have in communication, you could map it and talk now about compute at the edge, because say the application of driverless vehicles where the car is actually being supported from the edge with additional computational resources. In this case, what you need to deal with is being able to migrate these compute sessions, if you will, as the car moves around a region. So the idea that you can foresee the need to, just like what we've done with communication, that we might also need to develop interoperable protocols at the computational level, basically, to migrate these sessions. So that's another use case. And next. So defining metrics at the IETF, standardization of network information is quite mature, but when it comes to compute, yeah, it's just, I guess, work in progress, or if at all, because it's a little bit been done right now. So there's a need to define a set of compute metrics. Some ad hoc work exists in the IETF. So for instance, the CATS is also looking into the metrics from an operator standpoint and to support the steering of traffic within the network. So that's a specific use case. And in general, there's a need to support broader use cases as well, but that's a good development there. The Alto working group, which was recently finished at the charter, that has been focusing on exposure of communication metrics. So that's good. We have those RFCs there available. And then ops also as a potential area of interest, of course, there as well. And then, of course, metrics have also been defined in other forums, as mentioned, like Linux Foundation, etc. So something to look into and seek alignment as well. So we go next. So guiding principles, just at the two principles here that we'd like to seek as we go into this process. One is making sure that we leverage metrics across working groups, so we avoid reinventing the wheel. So that these metrics are in general common to a variety of use cases and these use cases might belong to different working groups. So making sure that we don't duplicate the work and that the decision of which metrics are developed is kind of a joint optimization process here. Secondly, also ensure that as we go through this process that we don't leave gaps, right? So making sure that the metrics we develop cover the important use cases and the use cases that we foresee at the same time, and that have some flexibility to incorporate future metrics as we progress, but ensuring that we don't leave gaps. So those two principles to help drive the conversation here. And then next, yeah, just a note that we had a couple of side meetings, one in 118, the other in 119. All the material has been recorded, so you have 2 repos with all the presentations, the video recording, the meeting minutes, so feel free to look at the material here. At this point, we are at the phase of collecting the state of the art and opening up conversations, and we're, and then making sure that people can collaborate and express their thoughts. We're going into a phase of processing this information, starting the dialogue on what people think is what should be done and why it should be done, and the focus of this effort. And then, if you're interested in this area, feel free to email us, and we can put you in the conversations that we were having. And there's a possibility of maybe getting a mailing list. So feel free to reach out to us. And I think that covers it.
Yep. Thank you. Any question?
Very quick one for clarification. Marco Lieb, NEC. You can go back to page number 6. So in general, I understand the intention here, but for that use case, you explicitly show 2 operators. So is that the key aspect of the problem, or is it, well, just because of...
Okay, yeah, good
I
question.
mean, the problem exists in general, is orthogonal, right? If you do that between administrative domains or within, the problem is the same in terms of transfer of compute, right? But if you do that between 2 administrative domains, you add more layers.
Yeah,
of complexity.
exactly. It's a good question. I mean, yeah, and we're considering whether to mention within the same operator or separate operators. I think this is applicable within the same operator. In general, you could have multi-operator, but that's even more challenging, right? So yeah, I mean, you can probably remove operator A and B from this slide and consider a case where you have these data centers located at the edge, and as the car moves, to meet the latency requirements, you might need to migrate that session from one compute physical resource to another compute located somewhere else, because now the latency requirement is not being met. So there's a need to migrate this compute workload from one location to another, and that could happen within the same operator, basically.
Okay,
yeah, thanks.
Daniel?
Oh, yeah. As you mentioned, that there are some similar works in the CATS group. So as I think your work is more relevant to the CATS. Why isn't why this work isn't in CATS? Thanks.
Yeah, thanks for the feedback. Yeah, I think that makes sense. I think that's part of the discussion. Luis will be presenting also during the CAT session, and we hope to have that conversation, I think. Yeah.
Okay, thank you.
Thank you.
We can, for a quick question, we can.
Hi, Colin Perkins. I think I was going to make similar feedback. I think it is really good to discuss the work widely, but there is obviously a lot of very related work going on in the IETF. in the CATS group, for example, in ALTO and places like that. So I would encourage you to take it to the relevant IETF working groups to make sure that the development of standardized metrics happens in a standards development organization and not a research group.
Yeah, thank you very much for the point. And yeah, I think that's principle number one, making sure that we leverage all the existing work. So definitely look forward to that. We look forward to that feedback as well. Really appreciate it. Yeah.
Okay, so thank you again.
Yeah, thank you.
Thank you. So now we'll enter we'll enter into the IBN, I would say, a session. So we'll start with Danyang. I will just put your slide and give you the control. Okay, should be okay. So the floor is yours.
Okay, thanks. Thanks. And now I will present the draft about the network management intent we proposed. So this slide is about the motivation and background. As we know, networks are becoming more and more complex. Highly heterogeneous and dynamic network infrastructure are bringing the ubiquitously connection, and network applications are various, such as the AR, VR, ubiquitous instant communications, pervasive intelligence, and so on. So all of these complexity network scenarios, services, and uncountable degrees of freedom, complexity of network management are leading to a complex system, and there will be more potential unknowns in the future. So we think that the traditional network management methods are insufficient to keep up with the growing requirements. So how to make the network efficiently is the problem we face. So for SNMP is the first network management techniques for small-scale networks focus on the configuration details of network devices. Then the policy-based network management can transform business requests and process into policies that configure and control networks. So based on those two, we want to propose an intent-based network management with the improvement of the network service capabilities and the diversification of our domains. Network management should be adapted to user services at a higher level. So the IDNM intent-driven network management has been emerged. So the intent-based network management architecture we proposed are shown as the red figure, and it is specific, measurable, achievable with rewarding and time-bound. Can be concluded in a smart architecture. So it contains, as we can see, it contains application layer and the intent-enabled layer and the infrastructure layer. And in the intent-enabled layer, it can be divided in the intent translation model. It achieves the measurable, and intelligent policy mapping model and is achievable, and the intent guarantee model, which is time-bound, and from the infrastructure layer to the intelligent enabled layer, it can have a rewarding pace. And from the application layer to the intelligent intent enabled layer, it can reach the specific. And as we can see, there are some AI methodologies can be used in the intent enabled layer to reach the goals we want to get. And the from the left figure, we can see that it's the whole architecture is from intent to policy to configuration, and is also have a feedback. The advantages of the smart architecture mentioned above can be concluded as that is a specific intent-driven network management architecture that can be used for diversified service intents with various scenarios, objectives, and preferences. This framework can achieve zero-touch management within time bound, which can handle the complex services in a fully automatic manner. The smart framework adapts to various complex network environments, and it is scalable, also avoiding network reconstruction. So in this slide, we will show the demo work we have been done. This use case is an intent-driven dynamic service function chain. The intent is to establish a standard level video service from user A in place B in place A to user B in place B. Uh, so in the intent input model, we enter the intent text box on the intent screen, then click submit will enter to the intent translation interface. And click the confirm button. We'll see that the intent will be successfully submitted, and um, from the after the intent translation, it will be it will it will be converted to a JavaScript object notation type. Then in the intent policy model, the JSON request will be divided into the service function chain and constructs the service function chain requests, and and after the intent policy, in the intent deployment model, OpenStack schedules network resources, constructs subnets and ports, and will generate two-dimensional space topology. And okay, our demo it has a video has been presented in the Wednesday side meeting. So so they will not be presented repeated. And future directions, we think there has more wider applications such as the cyberspace, smart grids, ICT supply chains, tactical communication networks, and so on. So we are also willing to explore more possibilities of IBN together. So as mentioned before, we make a specific system design of IBN, taking intent-based service function tree as an example. And the system demo was proposed in the SAN meeting. If interested, and you are very welcome to contact us for the link. So, and we are willing to contribute to a merging IBN use case draft. And also we see that that it's meaningful to compare and analyze different use cases in a single draft. Any comments? Thanks.
Any comment, question? Okay, just a quick comment from my side. Thank you for the presentation and also the presentation of the demos that was done on Wednesday SAN meeting. I think you can also share the link on the mailing list. Could be interesting that for people who were not there.
Okay, we will share it in the mailing list.
So thank you again. We have to move to the next presentation for sake of time.
Okay, thanks, Chair.
So next presenter, Paolo.
Hello.
Yep.
Yeah, this is Paolo. So yeah, we wanted to just give a brief update on and give directions on where we are going with this draft. Next slide, please. So what is the general intuition? I would say pretty basic. So it's on two coordinates. So first of all, we talk the space of interconnection, so multi-domain, interdomain. And essentially two coordinates is that like one, it's that there is very little work in terms of, automation and things like that. If not when the two providers are, peering, so they are doing some BGP, but you have interconnection in several other spaces. And the second is that like, in interconnection so far is pretty much, let's say, limited to IP. But in future you can have something more than that, right? So we are in the world of network as a service, network functions, and things like that. So we can be in a future where we don't want just to exchange, I advertise you this IP prefix and you advertise me that, but there could be more resources to it. I don't know, computing, you name it. Right, so very simple intuition here. Next slide, please. So essentially, like we can go next slide once more. So what we did since the last time, essentially, it's we took and we looked at what is happening in other forums, and for example, we updated like an example of what could be an intent with, this formula of expectation, target, condition, and context. So we looked in specifically at the mobile world, at 3GPP. Next slide, please. We added as well an example, like, you can have an interconnection, and then you have a target, like you want to define, I don't know, where is the interconnect taking place, the latencies on some constraint, bandwidth, and other stuff like that, right? So I would say everything super simple. Next slide, please. I will be super quick, you see. I will give all the time back. So the chairs, essentially, they were asking so what's going on here? What is the direction of this draft? So I would say what we are mainly doing is making friends and building bridges. So one thing is that we are, of course, looking at what what is happening in other forums, and they have similar cases, but not exactly the same. So we cannot just do a copy paste of what they are doing, but we could go, together, in a similar direction, let's say. Second thing, which is not mentioned in these slides because it's even more recent than, yesterday, it's that, let's say, in the Grow working group, they are talking about peering API. Right, so it's a very, very recent work that they are doing there. They did also a side meeting. And so in this, making friends and building bridges, probably we could also, look in that direction. Next slide. And yeah, essentially, this is what we are doing. Making friends, collecting feedback, and if you have any comments, that would be great.
Questions for Paulo?
No, it's just a great idea. Yeah.
Yeah, Qing, and interesting work. Actually, I see you, already explore some other forum. Actually, maybe one forum you're missing is a TMF forum. They also do the similar work like a intent metadata model. Maybe it could be good input as well. Yeah.
Thank you. Thank you. Thank you.
No?
In the slide, I think 2 or 3, depending on how you look at it. Yeah, so actually this is a similar question, I think, here. How do you envision actually that this interaction will happen across providers here? Could you elaborate on the use case for this one a little bit more?
Sure. So I would say that definitely I would see 2 main use cases. So in between providers, like provider A and provider B, for example, really for the peering, the interconnection between, I don't know, a cloud provider and, for example, over the top or whatever else, right? So, and they want to, or for example, like you are a cloud provider, let's say, and you that need some computing from there for your big data lake and things like that, right? So that could be one thing, so between providers. But I also see, and that is probably the work that we were doing in this last release of the draft, while looking at the 5G use case, it's not between 2 providers, but probably you are inside the same providers. There is, I don't know, 2 different worlds that want to talk to each other. I don't know, access and edge, for example. So those would be the 2 main things where we are looking at.
Okay, thanks.
Yeah.
Okay,
Thank you.
Again, Paulo. So next speaker is Paul. I will give you the control to the slide. Just a second.
Okay, can you hear me?
Yes, perfect.
Okay. So hello, this is Jean Porjan. Today I will introduce 2 drafts about intent-based networking for software-defined vehicle, and also the important element for intent-based networking, such as intent translation engine. So let me present the first draft. This draft is the intent-based management framework for software-defined vehicle intelligent transportation system. So my co-author, Chris, and I prepared this one. Next slide, please.
I think you can control the slide, Paul.
Oh, slide. Oh, I see. Okay, thank you.
Perfect.
Great. So basically, the objective of this draft is proposes a framework and interfaces of intent-based network management for unified configuration monitoring interfaces, such as network security application parameters in software-defined vehicle SDVs. We are working for IBM testbed for 5G, testbed for internet-based SDV management framework with free 5G for 5 core and radio access network, and also Kubernetes for container management, and also simulation for the SDV. We are using OMNet++ for simulation for networking, Sumo for mobility of vehicle, and also to simulate the AUTOSA, the inside vehicle network. We are using the MATLAB Simulink. The plan for implementation, we will design and implement the IBM testbed through IETF hackathon project this year. This IETF 109, we built 5G testbed. Next coming IETF 120 and 121, we keep working for our testbed. Design choice is we are using the back of the young lesson through the experience in the NSF working group. NSF stands for Interface Network Security Function for Cloud-Based Security Services. Next. So the encounter problem lessons, the design and implementation of intent translation engine, such as intent translator, is challenging. With the two different level, young data models such as high level from the user or customer, and also domain specific network API or cloud API case. Two models are quite different, so the translation is not easy. So we'll use our experience of ITNS security policy translator. So the ITNS translator of draft, you can click this one, you can find it. And also paper recently we published the security policy translator for network security functions in cloud-based security services for ITNSF. So you can also click this one. The positioning regarding IBM propositions and other draft. So we surveyed the Camara and TM Forum GSMA. They are working for northbound the interfaces. So we are focused on southbound interfaces for SDVs in vehicle network. Remaining challenge and the problem is we are working for intent translation engine with large language model, LLM. Next step, we will set up an SDV framework testbed and make an intent translator. So this is SDV. So basically SDV nowadays, hardware, software on top of AUTOSA, we can make software easily. So application layer can make some control or monitor for the electronic the control unit issue using AUTOSA runtime environment. So they providing operating system for the app developers. And also the COBISA is also the forum for connected vehicle system alliance based on W3C. So basically they collect the data and monitor using the REST API based data model. You can click this link. And also the Eclipse SDV, they are working provide the container runtime environment. So they are providing some driving assistance, quality management, many kinds of application based on the container. So our draft also based on this trend. So basically, this figure shows the virtual network for SDV. So in the middle, we have a virtual cloud, and also vehicle SDVs can communicate with over V2X. Also, edge server and central vehicle cloud can be used. So this draft propose the framework. Okay, so upside is the vehicle cloud, and bottom is the SDV framework. So our goal is to unify the configuration interfaces for network and security applications parameters. Also, we want to provide unified monitoring interfaces. This is detailed. Basically, translation is the first part. The second one also we consider closed loop control. Okay. So we are working this test bed. You can refer it. So next step, we clarify our draft. Also, we are working for design for the Yang for our framework. Okay. Okay, let's move on. Second draft. The second draft is intent translation engine for intent-based networking. The first author is Pedro. I'm co-author. So this figure is the main concept. So in the middle, we have an intent translation engine. Left-hand side, the tenant or customer gives intent. The intent is described using a resource description framework, RDF, schema, and also Yang. So basically, intent is delivered to intent translation engine, and then it generates specific domain-specific. Upper side, we have a management mechanism combination or network service definition. So network service or service application specific Yang or YAML-based the specific policy should be generated. Similarly, left-hand side, the control and management system CMS, also virtual infrastructure manager BIM in NFV framework. Also, they give a certain requirement of a policy, and the intent the translation engine can translate this one. So the guideline for our intent translation engine, so implementation guideline, we can abstract the algorithm we can consider, obtain a set of network service definition, and the composition of network management mechanism. Basically, input are described by resource definition framework, RDF schema, and then we can generate specific set of management mechanisms, also set up VNF and the resource. Okay, and then we can also validate and verify the required intent using closed loop control. So next step, we will make one step more for intent translation engine in terms of the mapping of RDF ontology and Yang data model for network APIs and cloud APIs. Also, we will consider the closed loop control for intent assurance and optimization by monitoring, analysis, and reconfiguration. So we keep working for IETF hackathon project for intent translation engine. Next hackathon, IETF 120. Thank you. So any question or comments? So the main slide has we have some slide for in-vehicle network configuration and other the specific required specification. You can refer it. Okay, thank you.
Thank you, Paul. Questions? So no question, Paul. So we are on time. Thank you.
Okay, thank you.
So now I will share with you some comments and feedback regarding the side meeting that we had on Wednesday. So let me just open the slide. Okay. So during this side meeting, of course, we have some let's say presentation to start the discussion and to somehow bootstrap the discussion. So there was a more detailed presentation of the intent translation engine that has been presented by Paul just before. Although, as we already said, the demo of the network management intent. And although one main objective of this meeting was to see how we can somehow work more in, let's say, in a collaborative manner on the different use cases to be able to somehow merge, at least integrate the different use cases. So just the few remarks. There are, let's say, 8 documents, individual drafts regarding use cases, not only in NMRG, but that are represented in NMRG as well. I mean, in terms of labeling of the name in the name. But what you observe is that there are all different level and details of maturity, which is normal because they does not start at the same time. They don't have the same objective. And there is no common approach to describe use case, which some ways, if you want to have a kind of good impact and visibility, we should be able to find a way to mature either each individual use case individually with investigation of the use case, with proposed solution, maybe some development and testing, or we can also think, and as it's one of our, let's say, we are also supporter of this idea. If we cannot reach an enough mature level for each individual use case, try to have a common approach in a document that could synthesize the different work done in the different use cases. Yeah, just another remark in different documents, of course, all the authors do not have the same objective. For some, it's just documenting a use case per se. For some, it's also documenting maybe a solution with some test. And for some, it's just going from maybe trying to reach a publication as I receive. For others, it's white paper, research paper as well, or implementations, as I already say. So that's why it's not very easy to combine all these maybe different use cases. Maybe we will not be able to combine all of them, but this was the idea of this meeting, to maybe bootstrap or rebootstrap this activity, because Jefferson at some years ago, I think, started to work on that perspective as well. So there is one proposition during the meeting which has been made which has been presented by Kian, but which comes from also other authors of use cases. Of course, the idea is they try to integrate the different documents you have in NMRG and propose a kind of what could be an outline. Of course, the idea is not to force people to join, but just to make a proposition here that I share also with you. So on the right side, you can see actually the proposition. So basically, there is a core section with the use case. They try somehow to map existing document to different use cases, and with some others that we need maybe some effort to document as well. And so, apart of that, they had, of course, in more, let's say, introduction content regarding what are the, let's say, needed component or part of IBM system to realize different use cases. Okay, yeah, just shorten a bit, just that it keeps on the page, but there are more, let's say, subsection. And also, I tried then to make connections with other topics within NMRG, in particular regarding artificial intelligence, network digital twin, and green networking. I summarize also here some of the comments that have been raised during the side meeting. One is that after describing the use case, we should have a kind of analysis about the use case in order to be able maybe to compare them, to assess what are the differences and commonalities. That means also we need a methodology, maybe some criteria to do. As already says, maybe the outputs that the author of the use case are targeting are different. So it means that maybe we need some alignment or some modification maybe in the outline to differentiate the different outputs, which means also maybe different timelines. You know, if somebody wants to first having all implementation, so it needs to be, of course, discussed if you want to integrate all of them. Also, another comment is that we have to, we should make reference to other IBM use cases that may appear in other groups, working groups here at IETF or in other SDOs. And as the research rules, or maybe more focus on methodological aspect, not only describing a use case, a problem to solve with IBM, but going a bit further. As there is, let's say it's more, I'd say, administrative issue, because you know we cannot have a list of 10 or 20 authors if you go for an RFE then. So we need to discuss about who will be main editors and who will be contributing authors in the document. Of course, I want really here to highlight that all of that is just a proposition. I mean, are not, let's say, we have to follow this, and other authors as well need to agree on that, let's say, template or outline and should join. But of course, for us, as chairs, we are really supporters this kind of idea to have a collective. Does not mean that all of them will need to fit in. If it's not work, it's not work. But we think that the effort should be made. So although it means that if you think that it's a good effort, also as use case authors, yes, we really would like to that the different authors join the discussion, see if, of course, their work could fit or not. And of course, joining the discussion does not mean that you agree to be in this joint document. So maybe you will evaluate with other what could be made, what change should be made maybe to the proposal here. And yeah, so we are really somehow we really would like that this continue. Maybe we'll of course support as the chairs this initiative, maybe by organizing side meeting, but we also appreciate that some of the authors of the use cases already take this some other lead on fostering the effort. And yes, that's it from my side. So any comment, feedback regarding I mean side meeting and this proposition regarding IBM use case?
Hello, Jerome. May I speak to something? This is Paul Zhang from SKKU.
Yep.
Okay. Can you hear me?
Yes, we get it.
Okay, sure. So basically, Jerome, he explained the clearly. The one minor comment and other suggestion is, so right side we have use cases. Use cases case the network planning, network construction, etc. There should be a subsection for use cases. So we try to explain each use case. For example, network planning, network construction, something like that. That is my comment. The other one is as Jerome mentioned. So I suggested split current authors or many IBM related document. So we finalize the 5 the editor authors, main authors, and contributors, including all authors from IBM document. And then we working for on this the merged draft before IETF 120 in Vancouver meeting. So we also hopefully we can have a 0.0 version before that meeting. Also, in interim meeting, also we can discuss our draft. So the first our step is we can finalize the main authors from volunteers people, and then we working for this draft. That's all. Thank you.
Thank you. Laurent?
Hello. That's good, the discussion on the different IBM use cases. Maybe some remarks. I think it would be interesting to seek some, let's say, alignment across the use cases, for instance, on terminology. This is relatively basic, but I think it could be a good helper if the use cases have a bit more harmonization of the terminology they use, because what we have seen already, for instance, just today, there are a similar concept, similar function, etc., but the naming is a bit different, the workflows are a bit different. So I think on this terminology alignment could be very useful. My second remark is to integrate maybe in this discussion about what to do with the use cases as a set, is what kind of research outcome we expect to produce. So I think there is individual value in each of the use cases. And I think we can try also to seek to have a bit of a collective value across the use cases, so to find commonalities, differences, and also from the research outcome, to capture, you see, in which areas the NMRG, through the use cases, through the work on IBM, is let's say, making some progress on the state of the art for this research domain. What has been, let's say, addressed, a bit solved, or has been progressed by this different proposal in the different use cases. So I think also thinking, you see, from the end, from the outcome, what we are looking to achieve altogether. I think it could be also, it should be a driver of these different use cases.
Thank you, Laurent. Diego, yeah.
My glasses on. No, just a comment to the point 16 on the integration of IBM, AI, and green. I can understand the integration of IBM and AI. With green is something that I'm fine. I'm not objecting, but you know, green is a characteristic, and I know that it's very fashionable, but I don't see the connection. The energy consumption and being more sustainable is something that is a desirable property, as could be stability, or could be fairness, or could be net neutrality, and we are not including them. It's simply that I am growing a little bit tired of seeing this everywhere. That's just a general reflection, not so. Exactly. So,
hi, Colin Perkins. I think I'd sort of like to echo the comments that Laurent made. You know, collecting use cases is fine and is useful and worthwhile, but reflecting on the use cases and trying to draw some insights is, you know, is a lot of the purpose of doing research and seeing if we can learn something from those use cases. So I would encourage not just collecting them into the draft, but seeing what insights can be derived from these.
Yeah. If I can just comment, yes, the idea is to avoid also just having a catalog of use cases, I would say, as Laurent say, and to have also kind of analysis of what could be the outcome, collective outcome, and it will be important also. And okay, I think we have to move to the next presentation now. Yeah, I think now it's network digital twin. Yeah. Just put the slide, and I leave the floor to Ashim. This one. No, I think we should work with. Just let me know when
Okay. Yeah. Good morning, everyone. Yes. So actually, Zoltan broke his leg. He cannot make a trip. So I, present on behalf of the author. And this work actually, one big motivation is, the chair already, scheduled the interim meeting. So we, just give you the update what has been discussed and how we can address these comments. So, so this draft, is, working with Java's current version number is 05. Next. And recapture a little bit, you can see actually in just before the IETF 119, actually, we already have an interim meeting to discuss, network digital twin architecture and key characteristics. And two relevant topics has been discussed. One is from, Zoltan, another from Chris. Actually, Chris actually have some, proposed modification. So we have a lot of good discussion, but three fundamental issues stand out. Actually, we list here. For example, for nano digital twin architecture, we actually try to model the key characteristic, identify 4 elements, for example, data, model, and mapping and interface. For interface, it can be broken down into the telemetry interface, control interface, intent interface. So the control, whether control is in the scope or not in the scope. So some people may concern, include this, control interface may make, this kind of, the action not, a little bit constrained or not reusable. And the second is, for nano digital twin, we need to, to see, how physical network can sync up data with, twin network actually. So this may rely on some kind of, interaction. We support like a real-time interaction or near real-time interaction. And also we support the bidirectional interaction. So this actually get discussed a little bit. We think we need to clarify. And third is, is more about, in this draft, actually, we have, some cover a more generic aspect, for some, requirements or characteristics, and also some specific aspect. So how we can differentiate, whether we need to separate both, actually make a good distinction, or do a little bit of restructure. So so based on interim meeting discussion, it agree actually maybe we can set up some kind of serial online meeting in the form of design team fashion actually to address all the remaining comments. Next. So the action to be taken already, actually, we set up the GitHub actually using, Markdown, and we invite all the calls and also some people who, contribute during the interim meeting to get together and add them as a collaborator. And we track, 70 issues, and just before the meeting, we close, 12 issue, but still, 5 remaining issues need to be resolved. So for any people who are interested in this kind of work, feel free, to join and to add your comments and contact us. Yeah. Next. The document status update. For the latest version, actually, we make a bunch of changes. The first is, is a naming issue, terminology actually, whether we call it nano digital twin or digital twin network. I think this is ping pong for many times on the mailing list, and actually we, based on the discussion also, we see some other STO like, ETSI or 3GPP also, they, try to study in this area. So we, for consistency, actually, we think we should choose, nano digital twin, make a, more alignment. Second, we update, nano digital twin definition in the terminology section, and also we actually make some, clarification change, for example, the interaction, and also how, nano digital twin can relate to the nano management system. So in the introduction, we try to see the nano digital twin as a tool, so this can be integrated with the nano management system. But we haven't do the the whole structural changing, but just flex such kind of concept in the introduction. Yeah, next. So several issues we want to provide to share with you. Actually, the first is about the architecture update. This is more related to the the scope of this nano digital twin. So you can see we actually nano digital twin can include 2 types of closed loop. First is in a closed loop, is in green box, more focused on emulation and optimization based on the data models. And second is we call the outer closed loop, which we really use some real data connect from the real network, or you can get some intent information from your applications, so we can do some validation and optimization. And I think this actually the question we get actually is about for scenario generation or scenario evaluation, how to position into this architecture. So we also have some offline discussion for this. We think for this scenario generation and the evaluation should not be part of the data repository, but it should be the digital twin network management entity. And we also think maybe for this architecture, we think may focus on in the closed loop, actually in green box, try to make it more reusable. For the for external closed loop, we will try to clarify how these nano digital twin as a tool can integrate with this control part or management system part. So but yeah, we're happy to receive more suggestions, comments. Actually, we can discuss how to better shape this kind of work. Yeah. Next. The second is actually is about sample use cases. The problem we facing is in current draft we discuss the key characteristics of the nano digital twin. For example, we have 4 elements. So, but how these 4 elements can be used in these typical scenarios, and what is the workflow look like? And so we give an example. Actually, this sample example and related to 5G nano slicing. This from China Mobile, they already demonstrating this TMF Catalyst project, and the goal is try to actually set priority for latency guarantee service. So, for example, you really want to deliver this 5G nano slicing service, you need to define some service intent or service configuration. You need to translate into the device level parameter and to make it apply. So so this we actually in these cases we set up the nano digital twin platform or emulation platform. We try to simulate the dynamic routing and forwarding path logic, and so you can see actually we can get topology data, also KPI data, and we can simulate how traffic goes through the different paths. Since we set the low latency requirements, so we first need to check whether the service that has been applied, whether they can meet these kind of requirements. It doesn't meet, actually we will call for this kind of simulation sandbox and to use some path computation algorithm, or combine with some AI algorithm to to calculate the better paths to satisfy these low latency requirements. And also we need to use this simulation environment to validate this configuration before this really populate this configuration into the network device. So this just to give you an example of how this nano digital twin can be used. Actually, you can see it cover several key components. For example, the how data can be connected, how data can be modeled, and we need to choose some scenario. We need to verify it. Actually, for example, you may need to add one more site or change some barrier parameter. This may cause some configuration change, but whether this configuration change will have impact on the service, for example, to make it meet the low latency requirements. So this really need to validate it. So we think this case could be a starting point to see how different elements we already identified can be used in this kind of scenario. Next. The third issue is about scope of nano digital draft. Actually, this outline of this draft, you can see we actually think maybe we should more focus on twin layer, interface layer. We think in the previous architecture we also try to discuss how nano digital twin platform can interact with the physical network, can interact with application. And I think this interact with application in some sense very useful. For example, scenario generation, you may rely on some application to generate some intent. So this interaction will be useful. But we think maybe better we need to focus on twin layer interface, but interface, also we may actually have different kind of interface, telemetry interface, intent interface, and control interface. This could be leave this as optional, and but how to better address this? We still need to figure out. We need to see, and also for the comments like generic aspect and specific aspect, I think currently we want to prioritize, some tasks, for example, nano digital twin definition and what is the key use cases, and also what is the key functionality we should really explore and define. So this make it more become the generic piece, can be not only can be used in IETF, but maybe can be better referenced in some other SDL, for example, ETSR, ZSM, or 3GPP. And for this job also, try to leverage IETF defined technology, and also mix with this kind of mature technology. But I think this job more focused on research part, so we need to figure out how to better do the separation or do some distinguishing. And so this is still the remaining issue for this job, and we happy to receive your suggesting input to better shape this draft. Next. For the future direction, I think probably chair will cover this as well. So we think from our standpoint of view, actually, we think besides what has already been documented, we think in the use cases we should have also need to focus on more sample use case, how the key elements or characteristics of the nano digital twin can be used. This is something we want to further investigate, and also how to characterize this nano digital twin. Maybe you have different type of nano digital twin, and we can maybe reference some concept from industry field, 401 in manufacturer field. Actually, there's a lot of good concept that we need to take a look at that, and also how this integrate with network management, especially in legacy part, and also knowledge is is also a very interesting part. We may think about how. So the overall, actually, we think if we see the nano digital as the reuser. Okay. Okay. So I think that's all from my side. Actually, we already set up a GitHub, and you can see the open issue. Feel free to add more issue we can discuss, and we'll target to get together facilitate progress of this work. So your comments input are welcome. Thank you.
Thank you. Before we enter into the, let's say, Q&A session, I will give the floor to Laurent to just give also some feedback from the chairs, and then we can discuss all together this.
Sorry, John. Are you referring to the chair proposal?
Yeah.
Okay.
We will share the slide if you want.
I mean, if you can get closer to the mic, we can hear you better.
Yeah, sure.
Okay, so again, this is just a bit of an assessment proposal to the group. Nothing prescriptive, but this is also based on the discussion in the interim dedicated to NDT and the different work that has been done since then by the different people involved on the architecture work. So our view is that as proposed, and this is not new, there are things that are known, things that are a bit new. So proposal for this architecture work to set up a kind of design team, open design team. So this is not a closed one, everybody can participate. But the idea is to try to have a bit of a more focused activity to make the progress, and especially to have something quite regular, online meetings to be able to progress on the key issues. Of course, all, let's say, decisions, progress should be reflected in the draft and draft of plural, and also towards the mailing list for every person in the research group to be able to see the progress. There is a question that we have, and so this is a proposal. Take it as a proposal. I think it's also what the authors are thinking, to consider splitting the draft. Maybe there could be different splits of the draft, but for us, for the chair, the rationale is to be able, because this document has been a research document for some time, it has parts that are relatively stable. So the idea of the rationale is to be able to separate aspects that are stable and already consensual in the group from the ongoing and open research questions, or more aspect that needs to be settled, and also to consider the product, the architecture as a final research result, and not to fix the architecture too early in the research phase, and also to allow the architecture to be able to evolve as we learn, as we grow with understanding of this technology. So to keep the architecture open and adaptable. So the proposal could be, again, this is just a proposal. We are not the authors of the draft. This is a suggestion from the chairs to consider a part that could be looking more into the network digital twin concepts and definitions, essentially part of the draft that are stable and consensual, to stabilize this content and proceed towards the publication of the NRFC. Then consider to have another part, which could be more looking into the architecture itself, or whatever equivalent we will come as naming, but that will look more into the principles, the functionality, structure, operations. So there is already this work in the draft, but also probably additional works to remain there, and to keep this part, this new document, as an open research working group document. The idea is to be able to fix intermediate version of this architecture as the working hypothesis, so that when we discuss in the group, when we progress on the research, we have still a reference, but this is a working reference, and we can even have this published. Then to be able to act as an in-progress reference architecture, so that when in the group we refer to something, we have this working hypothesis on the architecture. Keep the flexibility to adapt when we mature the understanding of the NDT, and also to be able to progress in parallel the different subtopics and the different use cases that we think will help us to revise and refine the architecture as we go. And then finally, but this is more as a conclusion, to be able to publish the architecture itself, the NDT architecture, as a conclusion of the work in the research group. So this is a proposal. It has some impact, of course, to keep a document open, but I think it's more an approach how we can really support the research and not fix an architecture. What our assessment was that if we fix too early, early in the process, an architecture, we will kind of keep bumping into having a strict framework in which we need to explore, instead of keeping the architecture open and allowing us to adapt to our new understanding. If you go to the next slide, Jérôme, please, then it will be done for this part of the comment. Then outside of the architectural work itself, you know that we have the discussion on this NDT research agenda to define it. So again, our proposal is to clarify and determine the different research questions in this domain, what kind of use cases, if we want to investigate use cases, and typically identify focus areas for NMRG. NDT is a wide research area, and we need to find which domains NMRG, the participants, agree to work on. This can also be an outcome, already an outcome. These research questions, for instance, in the PAN research group, they started already by listing some key questions for path-aware networking, and it has been, let's say, a defining document for the activity of the group. Then we need to organize the different research items, as we did, for instance, for IBN, we have research group milestones, and also link these different sub-items to the updates that will be on the architecture. So this is a previous point. Also, what we say on this research agenda, to use the previous experience in the group, for instance, how the IBN work, what was more or less successful, more or less progressing well, also from a time perspective, also autonomous networks, etc. So there are different experiences, and we want to learn from that in how we drive this research agenda. Then also from the research approaches for this topic to investigate, we have to be clear also what are the expectations in terms of the type of output we can produce. So there could be, let's say, more theoretical work, paper work, or also a combination with things that are a bit more applied, experimental, or implementation oriented. We have to see where we balance the different output, and also important to consider interaction with other communities, other groups that are working on NDT related work, because there are several also other groups that are actively defining other facets of the NDT. So for instance, also DT, purely digital twin technology, not network digital twin, research community and industry communities. Also from the standardization landscape and industry alliances, there is ongoing work there, and it's good to keep some synchronization alignment with them. And also, maybe to stress again that even if we are in the scope of IETF and RRTF, I will say that the research results it's not a must that all the research result of the research group must be in a form of an RFC. It is totally valid also to seek other forms of output, such as scientific papers. It could also be tools, it could be models, it could be implementation. So I think depending on the technology, depending on the question that we address, we need also to see what kind of output format we are looking for, because typically you see the RFC cycle is, even if we can make it quick, it's still quite process heavy cycle. So we need to also be clear that we can have other venues to publish the result of the group. Thank you.
Thank you, Laurent. So, Chris.
All right, hi, Chris Jans, Huawei. I see we just have 3 minutes left for discussion, so I'll keep it very short. So thank you to the authors for the continued work. I will jump in myself and help progress it. Guess we have to figure out if this is being split, how it's being split. If we want to freeze something which is concept only and not architecture, fine, but let's make sure we visibly take the existing draft, including architecture, sort of out of circulation, because rightly or wrongly, it's serving as a reference out there. And anyway, my basic point is that conceptually, on a concept level, there have been some improvements. I'm getting more comfortable with it. I still think the fundamental disagreement is, are we talking about different types of digital twins or different applications, use cases of a digital twin? In a concept level, you can wave your hands a bit. It's maybe not that important. When you get into architecture, though, that's a fundamental question, right? And you saw it exactly in your slide where you had the green box and you started talking about, okay, maybe that green box is really the digital twin, or at least the core of a digital twin, irrespective of the use case. Then you have inner closed loops and outer closed loops. Well, you do in some use cases, you don't in others, right? I mean, if you have a management plane planning application that's using the digital twin, it's not going to have control outputs. There'll be an inner closed loop only, for example, right? So, I mean, I think the way you approach architecture in these cases is on a modular basis. You say, the core of what we have here is this modeling or emulation or simulation function. It consumes data, twinning it to the real network. It provides analytics-based information. And then there are different ways of using that, right? It may be used in some optimization closed loop that might itself serve inside a control closed loop. But these are all use case dependencies. And these are the things that should be reflected correctly in architecture, right? So this is what I mean. If we're going to separate concept from and freeze that and then progress architecture, let's at least get that distinction, types of digital twins or use cases of digital twin, at least admit enough fuzziness that we don't hem ourselves in, and then sort of pull architecture out of commission until we can develop it further, right? At least make the statement that, look, we're not equating rigorously a digital twin with a network controller, right? And then we can go off and develop architecture as we see fit. Again, I don't think there's any disagreement about the fundamentals of what the digital twin is, right? It's not your grandfather's simulation emulation. It's network coupled. It uses live information. It's coupled to a real network. It's integrable in an operational engine. It is a software artifact. That's the key difference, how it's used and whether or not there's intent translators and control outputs. And those are all use case dependencies in my view. Okay, so thank you, and I will help you carry this forward.
Yes. Thanks, Chris. Actually, we already discussed this. I think probably we already on the same page for this and try to target this modular part, focus on, concept and yeah, for use cases and also some type of natural digital twin. Yeah, we can discuss, yeah, this where they should live to the, architecture to document. Yeah, thank you.
Hi, Colin Perkins. I think looking at this discussion, I'm seeing a lot of focus on what industry is doing and on what other standards organizations are doing, and of developing solid reference architectures that can be referred to by standards organizations. I think I would remind the group that this is a research group, and its goal is not to develop standard reference architectures and reference models. And the focus should be on the research questions rather than the engineering aspects and the standards development work should be happening in the IETF. So focus on the open research questions would be my suggestion for the group. This is an extremely active area, and the group seems to be moving at not a very active pace.
Yeah, so to just maybe to comment on that, that's why also part of the proposal is really to put the architecture.
You may need to closer.
Yeah, that's why we also support the idea just to split and put the architecture on another document, just to more, let's say, document the conceptual level, but also, yes, as you said, and also as Laurent said, just to more document also the related problems that will also support, in fine, also in my opinion, the research agenda we will have, or we would like to have in the group.
Sure, and that may well be the right approach, but again, I would encourage you to focus on the research papers, the research output, rather than on the output which is close to the standard space.
Thank you.
Yeah.
Okay, thank you.
Thank you.
So last presentation, Chris, I will put the slide.
Okay, so I'll try and do this in 8 minutes or less. So this was a topic that actually was brought up on our February interim call. I put this together with Dan King. Please, next slide. So, obviously a lot of focus in telemetry is packet oriented, so it deals with packet traffic, path discard, latency, other data. But there is, of course, in different types of networks, a whole other class of data that's interesting from a telemetry perspective, and that's what's more physically oriented. And here I'll focus on, by way of example, the optical network instrumentation being developed there, and use cases related to digital twin for the optical network and fault management for the optical network. Of course, really anything that, think physical, so if it concerns energy, wave propagation, et cetera, there may be parallels. Next slide. So, in optical networking, of course, for conditioning, commissioning, testing, troubleshooting operations, we've always had these instruments we lug around, things like OTDRs that can measure loss distribution, spectrum analyzers, et cetera. but really not a lot of embedded, constantly operating telemetry. There's been a lot of research the last few years that has developed a whole family of capabilities. Most of them are coherent receiver DSP based, where we have to compensate propagation impairments. So most of them are in fact measured, and we can synthesize a lot of other useful measurements at those points as well. Of course, the data that's generated is continuous time and it's real number, right? Next slide, please. So for the use cases quickly, the optical NDT and one flavor we've considered models transmission performance. It requires knowledge and modeling of fiber and service characteristics, transmission impairments, performance for operating connections. The state should reflect the real network condition and state. So imagine we can have these large volumes of continuous time real number telemetry measurement sources throughout the network. Obviously that poses a volumetric challenge to telemetry. Next slide. And there's another interesting case. There have been some developed methods where, you know, if you really develop a large amount of data over a limited period of time, you can take that data off the network and do some serious crunching of that data and get some very interesting information. So with a limited time data capture of the actual received IQ time-based waveforms in a coherent receiver, we can, through analysis, actually reconstruct a longitudinal loss profile on the optical path centered on a certain time interval. Also, it's understood now that polarization rotation dynamics, how those evolve, are correlated to physical disturbances of the fibers. So you can imagine there's the second mode, mostly for fault classification, localization, etc., that has to do with taking a big data dump around a certain period of time and then doing an offline analysis of that data. Next, please. Of course, there's a lot of resonance with things anticipated in the RFC 9232 network telemetry framework. So consider these more specific examples of what you might find there. Next slide. Obviously, you know, we need to do sampling. We need to do quantization of the samples. That's what has to go off the network. But I want to emphasize that it really should be at least couplets. There needs to be timestamps to go with the data. Various reasons for that, which will become clear as we go on. Okay, time precision, generally we're talking sort of network management time rather than digital time, but there are exceptions. Some of those captures for forensic analysis, those are digital time captures, but over very short intervals. Depending on how the data is being used, whether it's within a closed loop or something else, the time precision or the correlation among different data sources and time may be more or less important. Generally, it's pretty loose, though. What counts most is the time correlation among samples from a specific instrument. Okay. Pre-processing and post-processing, again, something anticipated in 9232. Obviously, you can do things like lossless compression. Of course, post-processing with decompression is unavoidable if you do that. Thresholding mechanisms were anticipated, and we find these quite useful, actually, and that can be, you know, you push when you exceed some absolute or proportional variation from the last transmitted data sample. You exceed some time rate of change of the measured value, or you exceed some previously observed maximum or minimum value. And those are interesting because they can achieve data reduction, but they don't always require post-processing. For the NDT application, for example, if all you want is the most recent data from every instrument in the network, well, within the precision limitations defined by how you set your thresholds, that is simply the last transmitted value from every instrument. So that can be useful. Next. Obviously, you can do things like normalization, conversion to frequency domain, generation of statistics as well. These are all possible pre-processing applications. Next. For the kinds of intense data sets for limited times that need that kind of forensic deep analysis, So here we think you can anticipate some kind of triggering mechanism, right? So you imagine within the embedded instrument, there's sort of a sliding data window, and then you look for triggers. Like, for example, if you're using data to reconstruct a longitudinal loss profile and try and figure out where and how some loss is appearing in the transmission path, well, logically, you would set some threshold for a loss of power or an increase in noise on that link. That would tell you, hey, something just happened that's relevant to the loss profile. I would trigger a capture, and that's what would go off board for analysis. Okay. Obviously, the streaming aspects of this, you can appreciate why programmability of those, specifically the kinds of pre-processing involved, would be interesting. Streaming versus polling, I mean, obviously these are all sort of, by default, push mechanisms, but it's worth considering whether polling nevertheless can't be useful. For example, for the NDT application, if you're doing NDT-based analyses relatively infrequently relative to the rate of change of key data, then polling may very well be adequate. You just need to, hey, I need to do a new planning exercise, I need to refresh my key data, I go out and poll it. That might be more efficient than constant updates floating around. Okay. Obviously, a complete framework, as anticipated by 9232, we would want telemetry clients to be able to identify what instrumentation with what telemetry, specifically what pre-processing capabilities are available in the network, to set up their subscriptions for streaming to that specific instrumentation, to program whatever pre-processing they want on specific instruments. Obviously, that includes applicable thresholds or triggers, et cetera, et cetera. And then, of course, models that govern the applicable timestamp data, value couplets or vectors or batches. Okay, and last. So next steps, I mean, we're working with someone to set up a convincing POC implementation, exercising that entire framework and sort of demonstrating how it can operate with this kind of instrumentation and these kinds of pre-processing. And of course, I think there's some common sort of generic aspects to this framework. Of course, this 9232 anticipated that if specific work is going on elsewhere in the IETF, that may be something we can support. That's all. Thank you.
Thank you.
Because we're out of time.
Yeah, but just on time. So
yeah.
If you have just a quick comment or question, we can take it. Yes.
Hi, Colin Perkins as an individual. This, reading this draft, I was struck with the commonalities with all the real-time streaming, video conferencing, telephony work that's been happening in the IETF. And none of that is referenced. So I'm certainly not saying you should use RTP for this, but there's obviously a whole batch of expertise in that community. So make sure this is part of this. You look at the way things are being done there and see if there's any lessons that can be learned.
Okay. Yeah. I mean, no one knows everything going on. So
of course. Yeah.
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 I did my best to start with what was findable through here in 9232. But
yeah. Of course, I'm not criticizing.
Okay.
I'm merely saying that there is a whole batch of other work that this community has done relating to these types of real-time data, and there seems to be some overlap in at least concepts. So I would encourage you to look at what that community's done.
Okay.
See if those lessons can be learned.
Okay. Yeah. Thank you.
Thank you again, Chris, and thank you all for joining the session. So this is the end of the session. Thank you. Thank you for the notes.
So I'm going to, to organize that and then I'll send you.
Yeah, sure.
Okay.
Yeah. It was a bit strange time, but
Yeah.
Anyway, I'm glad.